The example that we go over is a good one to write down. This is going to be the example that we work with for today. So we are going to evaluate this expression. I am recording it, yeah. I'm going to post it too. This one's a little bit more cumbersome than some of the other things that we've done. Yesterday when we were dividing numbers in scientific notation, a lot of that represented things we've already done. Properties of exponents and simplifying. This is a little bit different. So anything that you're a little unsure of, ask questions. It's going to be posted online, and we're going to practice at a time, so don't worry. If I wanted to add these two numbers together, first identify what form are they in? The 950,000, what form is that? What format? Yeah, this is standard form. The number is broken out, and we see that we're dealing with 950,000. How about this number? Yeah, this number is in scientific notation. So if I want to add them, what's the issue with them right now?
They're both in the same.
Yeah, they're not in the same format. So unless you're really fluid with these numbers, like how to convert a number really quickly to standard form or scientific notation, it might be a little bit challenging to add these. So what could we do to successfully add them together?
You could turn the scientific and standard.
I could take the scientific notation number, that 4.6 times 10 to the 7th, and I could break it out in standard form. Or what else could I do? I can take the number in standard form and put it in scientific notation. We are going to do both. Now, I like to start with the numbers in standard form because as you are learning how to do operations in scientific notation, it's going to give you an advantage if you know what the answer is going to be. You can kind of fix through some of the problems, and you'll see what I mean in a few minutes. We're going to do this in standard form first. What am I actually multiplying 4.6 by if I'm going to put it in standard form? I'm going to multiply by 10 by itself 7 times. So really, I have times 10, times 10, times 10, times 10, times 10, times 10, times 10. So what number do I have? I have 46 million.
Yes.
So now, think back to when you learned how to add. Now, if you do this on an assessment, you're not wrong, right? If you tell me the answer, you're not wrong. However, it's not going to be full credit if you just add them in standard form, right? That's the 8th grade standard, the learning target is that you can do these things in scientific notation, so keep that in mind.
Okay.
But some students might want to start with it in standard form just so they know, like, what is going on. When you learn how to add, just think way back, how would you add those two numbers?
I would line them up, the bigger one on top,
Okay.
and then I put the smaller one on the bottom. But I would line up their place value.
Okay. Why did that matter? Why, when you were in elementary school, were you taught that if you added, you had to line up numbers? What was the importance of that? Place value. It matters, right? I'm not just adding 4 and 6 and 9 and 5 here. I'm actually adding 46 million with 950,000. So if I added this, what is my answer?
46,950,000.
Good. So write that down so that you have it. Because when we go through this, we're going to go through this again in science. We're going to keep the numbers in scientific notation. Keep this number in mind. We already know what it is if we add them. Our answer should be 46,950,000. So when we add really large or really small numbers, we can have some issues. Sometimes the numbers are so big or so small that we have a lot of zeros. Right? There is room for error. So an option, one way to deal, is to keep these numbers in scientific notation. How can I convert 950,000 to scientific notation? If I write a number in scientific notation, just to recap, I have a number times 10 to an exponent. What do I know about this first number?
It has to be a number between 1 and 10.
Yeah, our proper scientific notation, this number would be between 1 and 10. What would that number be? 9.5. And I stress proper scientific notation because this is really what we've been working with since we started. Okay. And what would I multiply 9.5 by? 10 to the 5th. Good. So now I rewrote this number, and this is what I'm adding. We have 9.5 times 10 to the 5th plus 4.6 times 10 to the 7th. when you look at this, if you had to add these in scientific notation, what are you thinking right now? What are the thoughts going through your mind in terms of adding these numbers? Powers of 10, what about them? Add them, so like 10 to the 13th? Oh, I'm sorry, 12? Okay. And then what are we thinking for like the first number? Add the 9.5 and the 4.6. Okay, what would it be if I added 9.5 and 4.6?
14.8.
Okay, so think back. Look back to the number that you just wrote in standard form that is the answer to this problem. Is that the answer? No. The answer is 48,950,000. So something went wrong. Right? So that's not how we're going to add these. What issues do you see? Like there are some red flags here. There are some problems. What might be a problem?
We got to multiply what's the multiplier at?
Okay, well technically right now, these are two numbers being added together. I know you see that multiplication, right? That is, but they are still individual numbers. Like this is one number adding to another number. They just so happen to show multiplication because we're adding numbers that are in scientific notation. And we're not going to break them out in standard form. They're going to stay like that.
Why can't we, like, do that?
Think back. I don't know, we can
Why can't we do those rules? Like, why can't we have the 10 to the 5th plus the, like, yeah, like, why can't we combine them?
Would you subtract them?
What do you mean?
Why can't it be 10 to the 12th power? Or what?
If I added those numbers, now that the number on the left is 950,000, the number on the right is 48 million. So keep that in mind. Think about when you add. What are the things you need to pay really close attention to when you're adding numbers not in scientific notation?
The place value.
Okay, so what might be an issue when you have the numbers in scientific notation?
We don't
Oh,
have
you're only
place
using
value.
the numbers from 1 to 10.
They're not in the place.
Okay, so
They're not in the place value.
one's different. How do you know? You said that you're not on place value. What do you mean by we're not on the place value? Like if can I add the 9.5 and the 4.6?
Yeah.
Why not?
Well, because they're two separate numbers.
They are. They are.
But they're
They're
like half of the number.
What?
They're not the full number.
True, they're not the full number. But like the idea of like adding like the 9.5 and the 4.6 and the 10.5. Think about when you're adding it. You just told me when you add a number that's broken out, place value matters. Where's the place value here?
It's different because
Yeah. The powers of 10 represent the place value. So if I just add together the 9.5 and the 4.6, am I adding numbers in the same place value? No, I cannot do that. So what do you think I might want to do? If they're not in the same place value, what do I need in order to successfully add them? I need them to somehow be in the same place value. So is there something that I might be able to do to a number so that it is in the same place value?
multiply
You can move the 900, you can add,
You're on the right track.
you can multiply 100 to 9.5, like add 2 decimals.
I like where your head's at. You're on the right track. Right? We need somehow to represent these numbers in the same with the same place value. So what about them needs to be the same? If I need the place value to be the same, what needs to be the same? The exponent. And right now one of them is a 7 and one of them is a 5. So I somehow need to change one of them. Not changing the number, I'm just rewriting it.
Are we doing this kind of elimination thing?
Not really the word, but let's go through it. What number do you think we could rewrite? We can actually do either one, right? Either one. But let's work on this one. Right? If I wanted to work on this one. Okay, so there is a link here. Right now we have 9.5 times 10 to the 5th. And here we have 4.6 times 10 to the 7th. So if I have this number, what is this number really? Like if I broke everything out, what is it really? It's 4.6 times 10 times 10 times 10, 4, 5, 6, 7. But you just told me, right, that is the number. But you just told me that I wanted to represent this as the number times 10 to the 5th. So what would the first number be if I needed to represent this as a number times 10 to the 5th? Where do I get the 10 to the 5th? From inside the 10 to the 7th, you're totally right. If that represents my power of 10, what must my first number be? Remember, I'm not changing the number, I'm just rearranging my number. So if the 10 to the 5th is now my power of 10, what would this number be? We're multiplying. We're dividing. 460. So what did I do? Okay, I'm going to show you on the next slide. You're going to write it down. Then I'm going to show you a little interactive way on the bottom. So if we are going to put numbers into the same power of 10, right? And the real important thing is when we add numbers in scientific notation, we need the same exponents. And I'm going to put in parentheses here, place value. It represents the place value. Just like you line up numbers when you have them all broken out, this is almost how we're lining up our numbers in scientific notation. So let's see what we're doing. 4.6 times 10 to the 7th is the same thing as 4.6 times 10 to the 2nd times 10 to the 5th. The 2 and the 5 make 7. The reason I'm breaking it out, I need this number to be represented as 10 to the 5th, so I need the 10 squared to go somewhere else. I can actually use the associative property. For those of you that think about commutative property, you could argue that it's commutative property too, because you're changing the order, right? Everybody should be writing this down. Now, this is not in proper scientific notation for the time being, but it will be when we're done adding it together. So what are we really doing here? So my number is 4.6 times 10 to the 7. My number is not changing. I'm just taking 2 of the 10s and I'm moving them over here. Because I needed that second number, that power of 10, to be represented as a number to the 5th. So I really just changed the order. I regrouped it. Whether you look at that as associative property because we changed the grouping, or you look at it as the commutative property because the order changed. Either way, you are right. Because now my place value is lined up. Just take a moment, write it all down, try to see how we went from 10 to the 7 to 10 to the 5th, how the number went from 4.6 to 460. If there are parts of this that you're getting lost, please point out where that part is so we can focus specifically on that. did right now, we rewrote the numbers. So now they are both times 10 to the 5th. So now we're going to continue on. Now we're going to work on adding them together. Does anyone need more time writing? So now we have our numbers rewritten. We have 9.5 times 10 to the 5th plus 460 times 10 to the 5th. How do you think we add them?
9.5 times 10 to the power of 5 and 460 times 10 to the power of 5.
Can I now add the 460 and the 9.5? Yes. The exponent being the same tells me that that's really like the idea of lining them up, right? That's what we did. So we have 469.5. How about my exponent? 10. Wait.
How is it still to?
How is it still 5?
Think about
Oh, because it's when you're multiplying, you can add exponents, not when you're adding, you can add exponents.
So really that 5 represents these place values. So they don't, it's not like we're doubling them, right? That would stay. So now if this is where you got to, and you wrote down as your answer 469.5 times 10 to the 5th, you are not wrong. That is the right number. However, in terms of a grade, you'd probably be at a 3 right now. Why do you think it's not a 4 yet? Because that's not in proper scientific notation. Proper scientific notation, what do I know about that first number?
That has to be between 1 and 10.
Yes, so what would it be?
4.695 times 10 to the what number are we trying to get?
10 to the power of 5.
So here's the thing, look at this, look at this. Let me move this over. If we just write this number in scientific notation, just this one, pretend like you don't even see that, right? You would write what? 4.695 times 10 to what power? Just this one over here. Just to the second, because if this is my decimal times 1 times 10 and then times 10, so here. But I still have this. So before, when we took that 10 to the second, we like moved it to the term on the left. Now bring it back. Now don't assume. There's a few things I don't want you to assume. Don't assume that your answer is always going to be the exponent that's larger. It may not. Like here, it just worked out that we took the exponent of 7 in the beginning, we broke it out to a 5, and then it ended up being a 7 again. Don't assume that. May not happen. Now again, if you stopped at this level, you're not wrong. If you could, and I know you're all really strong at writing the numbers in scientific notation, this would be your perfect 100% answer. Now this is different. I know it's different.
It's more than different.
Do we feel like there's a specific point in which we were getting stuck when we wrote everything out?
The part where you moved them over.
Okay, the part where we regrouped.
Like when you took when you made the 4, 6, like when you made that new thing.
Okay, so we're going to take a look at another example where we do that. But what I want you to, actually I'll do this now. If you're writing this, did you write that? Let me see. Okay. Before we get to this, I actually want to pause here and kind of show you a little something. For this number here, this 9.5 times represent that number in a few ways. We could do, actually, let me move this down. How would I represent this number to the 6th? If I went from 10 to the 5th to 10 to the 6th, I'm multiplying this by 10. So what would I have to do to that number? I'd have to move the decimal down. To what number? What if it was 10 to the 7th? Our original number we already knew was 4.6. What if I wanted to show it as 10 to the 4th? So what's happening? These are the same number, every single one of them. The difference is I'm changing how I'm grouping my powers of 10. Here, to go every time I went down a layer, I'm taking a power of 10 away from the right side of the term. But if I'm not changing the value of the number, if I take it away from the right side, what do I have to do on the left side? I have to increase it by a power of 10. That's why this decimal is moving to here and then to here. See how this number on the left side is getting 10 times larger as my powers of 10 are getting 10 times smaller. Because at every layer, it's the same number. And you can use that as a strategy if you're trying to add numbers in scientific notation. You didn't have to break the 7 out. I could have actually just written the 9.5 as 10 to the 7. And when you break it out this way, you'll see a pattern over time. What would the 9.5 become if I went to 10 to the 4th? If this gets smaller by a power of 10, what does that become? A 95. And now let's go backwards. If I went from 10 to the 5th to 10 to the 6th, and this grew by a power of 10, what happens to 9.5? It becomes 0.95. What happens when I go back another power of 10? So if you wanted to stay at 10 to the 7th, that would have been, if I added it together, what? My answer would be 10 to the 7th. What's my first number? 4.6 plus 0.095. I still would have gotten the same answer. Pretty fancy, huh? Now take a look here. We're not going to sit on this one. The next one is what we're going to do. Can you add 3.5 times 10 to the 5th plus 4 times 10 to the 6th with the numbers written like they are?
No.
Why not? Because the exponents are not the same. So we would have to do something. So I want you to take a look here. And I want you to work on this one for like 3 minutes. Paul says that 3.14 times 10 to the 5th plus 2.53 times 10 to the 4th. He says that it equals 5.67 times 10 to the 5th. Is he right? I want you to work on this with the people around you. Did he make a mistake or not? If he made a mistake, where did he go wrong? If he made a mistake, can you do it right?